Right then guys, today we've got a nice sort of standard maths lecture. Are they lectures? Maths video, whatever they are. If you remember last week in the car crash video, I plucked this formula out of thin air and then we used it to prove this one, and then I said, oh yeah, you can use it to prove these two as well. So that's what we're going to do today. We're going to derive this formula and then prove these three formulae from it. So without further ado, let's get on with it. So let's start off with some definitions. You might remember from school. Sine of an angle. Let's draw the triangle. Okay. Right angle triangle. There's an angle A. This is opposite to the angle. This is adjacent to the angle. And this is the hypotenuse of the triangle. Okay, so remember your SOHCAHTOA. Do you remember that? So sine was O over H, and then cos of the angle is equal to A over H, and then tan of the angle is equal to O over A. Now we're going to rewrite this a little bit. So we're going to divide the top and bottom by H, and then we can substitute in these things. Look. So this is equal to sine A over cos A. Okay, so we're going to be using that in a bit to find this. Okay, so these are the definitions. We don't need to prove these. This is how we define a sine as a function from the angle to the ratio of the two sides. Okay, these are lengths. This is an angle, and we're going to use these. We're going to start from here to come up with this. But first of all, I need to construct some compound angle formulae for sine and cos. So imagine we've got, I'm going to draw it down here. Hopefully you can see that. Yeah, that's not bad. You've got an angle A there, and then on top of that, I'm going to draw another triangle, another right angle triangle, but this angle is going to be B. Okay, so this combined angle is A plus B. Now this is the crux of the argument. This is the trick. This is what you need to do to figure it out. You're going to go up here and across. You're drawing a rectangle around these two triangles. Okay, now we can work out this angle. Remember the angles on the line add up to 180. Also the angles in the triangle add up to 180. Therefore this angle is 90 minus A plus 90 means this angle must also be A for it to add up to 180. This is a right angle, and then this angle is A plus B. We know that because this entire angle here is A plus B. These top and bottom lines of a rectangle are parallel, and then if you have two parallel lines and a line intersecting, this angle and this angle are the same. I think that's one of Euclid's axioms, might be something like that, isn't it? But it's definitely true, so that's okay. These are all right angles as well. So we're going to label the sides. There's going to be quite a few sides we're going to be labelling, so just try and keep track. A, B, C, D, E, F, where are we? G, H and I. Okay, so we've got lots of angles, lots of sides. So now we're going to try and figure out, because we want tan of A plus B, we're going to try and figure out sine of A plus B and cos of A plus B, and then we're going to divide them to give us the tan. But we're going to do it in a sec though. First of all, we're going to write down sine of A. That is equal to, from our rule, O over H, this is length A divided by length G. Okay, but it's also equal to, we've got another triangle here with an angle A in it, so we can use that one as well. This is the opposite, this is the hypotenuse, so we can write that as C of H as well. We're going to use both of these results. As you'll see in a sec. Cos of A, we can use exactly the same logic. We'll get two results as well. Is adjacent over hypotenuse, that's f over g, but it's also equal to b over h. Okay, now sine of b, we only have one triangle with an angle b in it, so we can just write that opposite over hypotenuse, h over I, and cos of b equals g over I. Okay, now what we're going to do, now we're going to do the next step. Now we're going to have sine of a over b, a plus b. Well, what triangle do we have here with a plus b in it? Well, we have this big one here, so that's equal to opposite over hypotenuse, that's e over I. We don't have any formula here with e in it, so what can we do? We can put e, because it's the side of a rectangle, it's going to be equal to the other side of the rectangle as well, so it's a plus b. Okay, well, that's equal to, we can, that's how fractions work, plus b over I. Now we nearly there. Look, we've got some stuff over I and some stuff over b over a over something and b over something. So what can we do? Just like we did here, we can multiply top and bottom by g. So we get a over g plus g over I plus this is equal to b over h times h over I. Now we have this in terms of things we've got here. So let's put it in. A over g is sine a. G over I is cos b plus b over h cos a, and then what's the last thing? H over I is sine b. So here we've got a formula for sine a plus b. I'm going to write it up here, it's an important one, this. Okay, so that's our sine a plus b. We're going to do exactly the same thing with cos. If you want to have a go yourself, pause the video and have a quick go. It's the same sort of thing. We're going to use the various triangles and these results to get the cos a plus b. Well, this is equal to, we've got this triangle again, d over I. We don't have any expression with d in it, so how can we write d in terms of the other things? Well, d plus c equals f, therefore d equals f minus c. And again, that's f over I minus c over I. That's equal to f over g times g over I minus c over h times h over I, and that's equal to cos a cos b minus sine a sine b. Again, that's the important result. I'll write that one up here. Okay, so now we can get rid of this. And start turning all this into tangents. So we know tan a plus b from our definitions is equal to sine a plus b over cos a plus b. And from these formula we just derived, that's equal to sine a cos b plus sine b cos a over cos a cos b minus sine a sine b. Now we want to get rid of these sines and coses in terms of turn them into tans, like in this formula here. Okay, so what we're going to do first of all is again divide top and bottom everything by cos a. See what we get. Well, we get sine a over cos a is tan a times cos b plus sine b times cos a over cos a is 1, so that's just sine b. And then divide by, again, cos a divided by cos a is 1, so that's just cos b minus, and then we've got sine over cos is tan a sine b. Now what we do is divide everything by cos of b. That gives us tan a times cos of b divided by cos of b, which is 1. Sine B over cos B is tan B. Hey, look at this. Getting it, aren't we? Cos B divided by cos B is 1. Anything divided by itself is 1. And then we have tan A. Sine over cos is tan. And so there we go. That's our result there. Got there. Phew. So give that a tick. Got it. So now we're going to use that to derive these three formulae here. The first one is relatively straightforward. I think I did go through it, but we'll go over it one more time. If we set A equal to B equal to alpha, then we have tan of 2 alpha equals tan alpha plus alpha. That equals tan alpha plus tan alpha over 1 minus tan alpha tan alpha. I just tidied it up a bit. That gives us 2 tan alpha over 1 minus tan squared alpha, and that's our result there. Excellent. Now we're going to use both of these results with this one. We're going to set A equals to 2 alpha, B equals alpha, and then put them in here. So we get tan 3 alpha is equal to tan 2 alpha plus alpha. That's A and B. That's equal to tan 2 alpha plus tan alpha over 1 minus tan 2 alpha tan alpha. And now we use this formula in here and it gets messy. So we say this is 2 tan alpha over 1 minus tan squared alpha. That's that. Plus tan alpha over 1 minus, and again times tan alpha. Okay, if we multiply the top and bottom by 1 minus tan squared alpha, we get 2 tan alpha, that cancels out, plus tan alpha 1 minus tan squared alpha over 1 times 1 minus tan squared alpha minus 2 tan alpha times tan alpha, so that's 2 tan squared alpha equals, so this will be tan alpha minus tan cubed alpha. So this is 2 tan alpha plus 1 tan alpha is 3 tan alpha minus tan cubed alpha over 1 minus 3 lots. Minus 1 minus 2 is minus 3 tan squared alpha. Hopefully that agrees. We've got 3 tan alpha minus tan cubed over 1 minus 3 tan squared. Okay, 1 to go. So there are 2 ways of doing this one. We can say it's A equals 3 alpha and B equals alpha, because 4 alpha is obviously equal to 3 alpha plus alpha. Or we can say A equals B equals 2 alpha, because that's equal to 2 alpha plus 2 alpha. I'm going to use this method. Have a go with the other one to make sure you get the same result. Hopefully you do. So let's have a go. Right, so we have tan, it's going to be even messier I think this one, equals tan 2 alpha plus 2 alpha equals, so tan 2 alpha plus tan 2 alpha over 1 minus tan 2 alpha tan 2 alpha. So that's using that rule. Now we're going to use this rule and put all these, change all these tan 2 alphas into this. So that's equal to 2 tan alpha over 1 minus tan squared alpha plus 2 tan alpha over 1 minus tan all over 1 minus, and then we have 2 tan alpha over 1 minus tan squared Now all we have to do is tidy this up a bit. If we multiply top and bottom by 1 minus tan squared alpha squared, because we've got two of them on the bottom here which we want to get rid of, that will give us, well, this is 2 tan alpha plus 2 tan alpha is 4 tan alpha. One of the 1 minus tan squared alphas cancels, and then we're left to multiply this by the remaining 1 minus tan squared alpha, and that's then going to be over 1 minus tan squared alpha squared minus 4 tan squared alpha. That's 2 tan alpha times 2 tan alpha. Okay, so the top becomes 4 tan alpha minus 4 tan cubed alpha, and this multiply out becomes 1 minus 2 tan squared alpha plus tan to the 4 alpha minus this one tan squared alpha, and we put it here. One 2 tan squared minus 4 tan squared is minus 6 tan squared. Boom. So that's it for today. Have a go with this method, as I said, but should get the same result. Give me a tick. Okay, and the main take-home message is try and remember these formula, or at least be able to derive them using our funky construction. That one, because you use them a lot. Okay, in calculus when you figure out how to differentiate the trigonometric functions, all sorts. But that's all we're going to do today. So I hope you enjoyed it, and I'll see you next time.